We're going to introduce today how to start solving a two-body problem. Just like we've done in the past, we're going to look at each object and draw in the forces acting on that object. So the normal force, the force of gravity. We're going to refer to this block as M2. So since we have two objects now, we have to write M2G. And no friction right now. Tension. So there's block 2. On block 1, we have tension, and we have the force of gravity. We're also going to draw in the direction of acceleration for both of these boxes. The next step is also the same for these. We're going to start with block 2, and we're going to write the X force and the Y force. In the X direction, we have tension. Right there. And that's going to equal MA. But it's going to equal M2A. In the Y direction, we have N minus M2G. And again, that's going to equal 0 because there's no acceleration in the Y direction. We're going to come to block 1 now. If we take a look at the direction of acceleration, I am going to call that direction positive. So when I write my F net Y, there is no F net X, I am going to write it in terms of down being positive. So M1G minus tension equals M1A. If you want to stay with calling up positive, your equation would look like this. T minus M1G equals, and this is the important part right here, negative M1A. Because we know it's accelerating down, since we call gravity down for that equation. They're both the same equation, just rearranged a little bit. So the next step is recognizing what is equal between the two objects. Well, what is equal is the tension is the same along with the acceleration. So if we come over here and we look at what we have two equations and two unknowns. This is called a system of equations. So to solve the system of equations, we are going to take our first equation, T equals M1A. We're going to take our second equation from block 1 and solve for T. T equals M1G minus M1A. Oh, excuse me. This is M2. These tensions are the same. So I can set M2A equal to M1G minus M1A. Do a little algebra here. Add M1A to both sides, so that cancels that out. And I'm left with this. M1A plus M2A equals M2G. And factor out an A, and we're left with this. The value for acceleration. That is how you solve a two-body problem.